Hey guys, so I'm going to go through those substitution example problems for you. So in case you missed it in class today, you have them worked out for you and can follow along. So again, with substitution, remember your goal is to take one equation and plug it completely into the other. So if I take a look at number 15, first off, I also want to make sure you know you're always going to substitute the y, because if I ever try and substitute x, it's going to get a little iffy and with those x squareds. So we always want to substitute y. That's going to make your life so much easier that way. So in this problem, I'm going to substitute the x plus 5 into the y in the second equation. Okay, if I had anything to distribute, I would distribute. I don't. And now my goal is I need to solve this. So step 1, again, substitute. Okay, step 2, we're going to solve now. When we solve this quadratic, our goal, anytime I have a quadratic, is to get one side to be 0. So then we can either attempt to factor it or use the quadratic formula. We could also possibly use square root method if I only have a single term. So it just depends on what you have in the problem. So in this case, we get one side to be 0 by subtracting the x and subtracting the 5. Okay, and we're at this point here. So from here, again, you can choose whatever method you find easiest. To me, personally, it is easiest to factor. But if you don't like factoring, go for the quadratic formula. So in this case, if I go to factor, okay, first times the last is -3. Middle term, -2. So factors of -3 that add to -2 are a -3 and a +1. Since this is a leading coefficient of 1, I can use my diamond method shortcut and just use my factors. X minus 3, x plus 1. Again, reminder, when you have to solve these, you set each one equal to 0, and then you would solve. So in this case, we have x equals 3, and x equals -1. Once we have our two solutions, or however many solutions we might have, our third step is to find y. So I'm going to take the first one, just because it's smaller. So the y equals x plus 5. And I'm going to place the 3 in and find a solution. And then I'm going to place the -1 in and find a solution. So this gets me y equals 8 and y equals 4. So when all is said and done here, I can write my ordered pairs as 3, 8. And then -1, 4. Again, like I said, when we were doing graphing, you could graph the two equations. You could graph these two here, put them in Desmos, and see, is that what you're going to end up getting once you graph it? But if I ask you to do substitution, I do need to see all this work. Okay, but you can use the graphing method to help you narrow it down, or to check your work, I should say. Okay, let's take a look at number 17. Okay, so I have x squared plus y squared equals 64, and then y equals -8. We love these kind of questions because I already know what y is. Y is -8. It's a number. We like that. We're going to take it, plug it in to the y in the previous problem. When we do that and we go forth and solve it, well, -8 squared, because that was a y squared, is 64. Okay, and now this case, I only have a single x squared, so I can attempt to solve it by the square root method. I'm going to subtract 64. I get x squared equals 0. Well, when I square root it, square root of 0 is still 0. Just remember, when you do square root numbers, you do have to put the plus or minus there. So it's plus or minus 0, but 0 has no sign, so it's just 0. And I don't have to worry about plugging anything back in because I already know the y. Y is -8. If you wanted to, you could plug in the 0 and get a solution, completely up to you, but we know that y is -8 from the given problem. All right, number 19. So number 19 is a little different because neither one of them say y equals. But when this happens, you take one of them and you transfer it around. So in this case, that bottom one is easy to get y by itself. Just add 2x to both sides. So now we're looking at y equals 2x minus 4. I can then take this and plug it into the y here. Oops. Okay, so again, where that y was, I'm putting in a 2x minus 4. Now from here, I got to distribute this minus sign into both. So it just changes our signs back here. I'm then going to combine my like terms. And just for a matter of space and time, I'm also going to add the 3 over to combine my numbers on both sides. So I get 2x squared plus 2x plus 7 equals 0. Now at this point, again, we got to solve it. You can choose to factor. You can choose quadratic formula. Whenever I see a leading coefficient, I'm going to use the quadratic formula. I know it. It's easy enough to use, right? Your negative b plus or minus square root of b squared minus 4ac all over 2a. Just because if I have that leading coefficient, factoring just gets a little iffy. But I can find a, b's, and c's and plug them in. Okay. Remember our first part, we're going to find the discriminant. Okay. So let's label these. My a is 2. My b is also 2. And my c is 7. So when I go through and I put it in my discriminant formula, so I have 2 in the A, 2 in the B, oops, keep it color-coded, 2 in the B, and C is 7. And then you go through and you simplify it. Well, 2 squared is 4, 4 times 2 is 8, 8 times 7 is 56. So this is a negative 52. So the fact that this is negative tells me I have no real solution. Because if I was to put that back into the radical, into my full quadratic formula, I would attempt to solve that and end up with a negative inside a radical, which is an imaginary number. And we don't want imaginary numbers. We want to know what are the real solutions. Where would we see these crossing? This actually ended up being the do now problem that you guys did in class today, that you had a graph in Desmos. You put these equations in there and they didn't cross. So we already knew it was a no solution. Okay. Let's go back over here. Oops. Clear out 15. I'm going to clear out 17 also. All right, so let's take a look at number 21. So 21, it's already set up. I have a y by itself, so that's nice. So again, we're going to start by substituting, taking what it equals, putting it into the other problem. So negative 7 equals a negative x squared minus, and then x squared minus 1 is going inside. Just like the previous problem in 19, I got to distribute this negative sign. So we have negative 7 equals negative x squared minus x squared plus 1. All right, so again, we're going to combine our like terms here. So I got negative 7 equals negative 2x squared plus 1. Now again, this is a single x squared. You could choose to do the quadratic formula here. You can move that negative 7 over. Then you just don't have a b term. But in this case, it's actually easier and quicker to use your square root method. Subtract the 1, get that x squared by itself. Divide by a negative 2. Now it gets me a positive 4 over here equals x squared. And we're going to square root. And again, when we square root, you have to remember to put a plus or minus. So I have two answers. I have a positive 2 and I have a negative 2. So again, do not forget that when you are going through and doing these problems. So let me scroll down here. Let's clear that out. Now we got to figure out, well, what are the y's? If these are my x's, I'm going to take my y equation, which was y equals x squared minus 1. I'm going to do it twice. Once where x equaled the positive 2, and once where it equaled the negative 2. So we're going to plug them in. And solve. So y equals 2 squared minus 1. Well, 2 squared is 4. 4 minus 1 is 3. So I have the ordered pair 2, 3. And then I'm going to do the same thing on this side with a negative 2. Well, negative 2 squared is also 4. 4 minus 1 is still 3. But I have the ordered pair negative 2, 3 at this point. So again, they're not the same. They're not identical. One's positive, one's negative of the 2's, but they ended up getting me the same y value, which is fine. I still have to write the same 2 ordered pairs. All right, and the last question, number 23. I'm going to clear out number 19 over here before we start. Okay, 23. So you have x squared plus y squared equals 7. X plus 3y equals 21. Okay, so you actually can get y by itself in this case, or x by itself. And the only reason I say you can do x in this case, and I stressed before it should always be y, is because no matter what I'm substituting, I have both squared. I have an x squared and a y squared, so it doesn't matter at this point. So I'm going to choose to do x by itself, just because the x is easy to get alone just by subtracting this negative 3y. So then this becomes x equals negative 3y plus 21. Again, if you chose to get your y by itself, and I can show you that too, if you chose to do the y, in that case, you would have had 3y equals negative x plus 21, and then you would have had to divide. And look, now we got fractions happening here. Doesn't mean you can't do it. You can still do the whole problem. You would just have fractions, okay? But I'm going to stick over here with the x because there's no fractions there. It's going to make life easier. And we're going to put it into the x in this problem. Okay, so you have negative 3y plus 21 equals, or sorry, squared plus y squared equals 7. Now remember, a square means there's 2 of them. So I'm going to write this twice. And then I got to FOIL it. So negative 3y times negative 3y is a positive 9y squared. Negative 3y times 21 is a negative 63y. 21 times negative 3 is another negative 63y. And then 21 times 21 is 441 plus y squared equals 7. We're going to combine our like terms. So I have the y squareds here, and I'm going to move the 7 over just all at the same time to save space. So we have 10y squared minus 126y plus 434 equals 0. Again, I'm not even going to try to factor that. I'm going to start right in with my discriminant and see what I get. So A is 10, B is negative 126, C is 433. So my discriminant, again, is going to be B squared minus 4 times A times C. So let's fill these in. Negative 126, 4 times 10 times 434. And if you put that in your calculator, this comes out to be 15,876 minus 17,387 360, which is a negative 1484. Again, it's a negative discriminant, which tells me I have no real solutions. Okay. And again, had you gone through with the y, you would have ended up with the exact same no real solution. You would have had a different negative value when you tested out your discriminant, but it still would have been negative, and you would have had a no real solution.